Tuesday, you see a function. We're going to put together everything we've learned so far. A function defined on an interval, and it's defined at point A. What we want to do now is, as it's defined at point A, we want to be able to find the slope of the line tangent at that spot, connecting all the pieces we've done so far. And so what we're going to do is we're going to draw that tangent line at A, and so the output will be f of A. Oh. However, we know that finding the equation for a line tangent is difficult with one point. So we'll create a second point, and I will call that at point X. So what is the output value? F of X. And so what I have here now is, let's see, what do I got? Oh, yeah, I got a secant line. The slope of the secant line estimates the slope of the tangent line, and to approximate more closely, what do we do with X? Bring it closer to A. So let's put all this in mathematical notation. Calculus was developed really by Archimedes back in the year 200 BC, but it took until the year 1600 AD for us to put it formally together, and that was through the piece of limits. And so this stuff that you're going to see right now connects everything we've done, and it's awesome. You need a slope of a tangent line. If you want to write an equation, you need a point on a line. What's going to be the point on your line to write an equation for a line? What's going to be the point on the line for this one right here? What, A and f of A, okay? So that'll be the point on the line if we want to write the equation. But the slope is equal to, well, let's focus on the secant line. Let's take x sub 2 minus x sub 1. I'm sorry, y sub 2 minus y sub 1. F of x minus f of A all over x minus A. Now, Maddie, what did you say we do in order to make sure that that slope, instead of being the secant line, will be the tangent line? We bring x closer to A. So we allow the limit as x approaches A. And if we can evaluate that limit, now we know the exact slope. And that's awesome sauce. So we're going to call this right here definition 1. We're going to call that definition number 1. And I'm going to teach you how to use definition 1. And then I'm going to show you how to use what we call definition number 2 later on. Okay? The fact is that every single time that we write this type of equation, there's something beautiful that happens that you've already studied. We'll piece it all together. Find the equation for the line tangent. In order to do that, I need a point on a line, and I need slope. I already know my point on my line. It's 1, negative 2. What if they didn't give us the negative 2? How do we find out negative 2? You plug it in. Great, so I want to find my slope. I know the slope is equal to the limit as x approaches 1. 1 of f of x minus negative 2, so plus 2 all over. So the slope is equal to the limit as x goes to 1 of x squared minus 1 over x minus 1. Pause right there. Is that continuous or discontinuous at x equals 1? It's discontinuous. Everybody agree that's discontinuous? So, as we've talked about discontinuity, there's really 3 types. Number 1, you can have a jump, which looks like this, okay? Where literally you got to pick up your pencil and move it somewhere else to draw it. You also have these infinite discontinuities. But you also have this very special one that we've talked about, which is a removable discontinuity. Okay, we've seen that where you have functions that got a hole right in the middle of it, right? Well, this one has a hole right in the middle of it. How do we find that? What do we do? What do we do to remove it? How do I make it so it's not discontinuous? What do I do? I factor it. The limit as x goes to 1 of x plus 1 times x minus 1 over x minus 1. Remember from your assignment the other day, we filled the discontinuity? That's what the slope ends up being. You cross that off, and then you fill the discontinuity. How do we do that? Yeah, you could write a piecewise function, but we won't do all that work. We'll simply just plug it in. 1 plus 1 is 2. Slope is 2. Done. Now I know the slope, so I can write my equation for my line tangent. Y plus 2 on the AP exam, you can leave the answer like that. But you got to write it in slope-intercept form in this class. Done. That's the equation for my line tangent. That's super awesome. I can now take that, plug in my calculator, press graph, boom, checked, done. It's pretty amazing. Slope at 1 point, folks. Slope at 1 point. Not an estimation. Note before when we were doing limits and we were plugging our calculator, we were approaching, we're going to the table, we're like, okay, let's approach a number. Okay, we are actually verifying this is a removable discontinuity. We're filling the discontinuity. This is exact. We've used the idea of limits. You do B on your own. Go. Again, if you want to check your work, you can either look at my work on the board or you can check your graphic calculator. But your equation for your line tangent should be y equals 12x minus 13. What do you think? These are polynomials. What we're going to do, 30 seconds, you're going to break for lunch. But what we're going to do when we get back is we have to figure out what to do if they've got a radical. What do we do if they're a rational function? Yes. It's the x value. Yep, it's the x value that's approaching. Okay. All right. When the bell goes, go get some brain food. Come on back. All right. So anyway, that it's like you talk about a day maker. That's like a year maker. You know what I mean? Oh, you know what I mean? Like somebody cares about me. I got my week maker last week from Miss Nelson. A little. Yeah, that was awesome. It was very nice. Okay, here we go. We're gonna do another one. Find equation for line tangent the function. Given point using equation 2. So I have my point on my line. Let me find the slope. Slope is equal to the limit as x goes to what? 6 of the root of x minus 2 minus what? 2 all over. Sweet. All right, so I want to be able to, I got to get rid of this x minus 6. And again, it may not look like it is, but it is a removable discontinuity. We just got to remove it, fill it, be done. Okay? So, any thoughts? You know how to do this problem already, but we'll see if you multiply what? Conjugate. Yes, conjugate. Thank you. So we're going to multiply square root of x minus 2 plus 2 over the square root of x minus 2 plus 2. Now be careful with your fancy-dancy algebra, okay? Don't get ahead of the game. You want to get rid of this x minus 6, correct? Do you see an x minus 6 yet? No. So, but make sure that you keep that set aside so that we can cancel it. So square root of x minus 2 times square root of x minus 2. X minus 2. What's going to happen in the middles? Go away. Negative 2 times positive 2. Now do you see your x minus 6? All over. And then we're going to write that as a binomial, x minus 6, so we understand that it will cancel with the binomial in the numerator. And then I'm going to have this whole piece left over. And you might say, well, it doesn't look real nice. It doesn't have to. We just have to get rid of the removable discontinuity so we can plug something in. She just emailed me. All right. So everybody agree this will be an x minus 6 over an x minus 6? So I'll get a 1 over x minus 2 plus 2. Can I plug in the 6 now? So, and understand when you're plugging in this 6 now, you're filling that removable discontinuity. That's what's happening, okay? And so as we do that, we get 6 minus 2 is 4, square root is 4, plus 2 is 4, so I get 1 over 4. Yeah. So that's the slope. Okay, can we skip writing the equation for line tangent? I think you guys know how to do that, right? Oh, I thought you had a question. Okay, let's look at the last one. Oh, you'll do that, trust me. I'm giving you a worksheet today and you'll know to do that. Let's look at B. I have the wrong y value here. It should not be 1/2. Yes. I know. Yep. We went over this last. Yep. Maddie and I both struggled to say our NGs. That's just the way it is. Like something's right, something's wrong. Wrong. All right. So, Maddie, just one more reason why we're awesome. Okay, thank you. All right. Yeah. All right. So back to the problem. I have the incorrect y value. So the y value is incorrect. Can you tell me what the correct y value is? One. Why, Claire? Plug in 2, you get 1. So it should be 1. So on your assignment today, don't give you the y value. You got to figure it out just like that. Okay. So we want to find the slope. The slope is equal to the limit as x goes to what? 2 of 1 over x minus 1 minus 1 all over x minus 2. We have a complex fraction, correct? So I'm going to multiply top and bottom by x minus 1. I'm going to get the slope is equal to the limit as x goes to 2 of a 1 minus x plus 1 over x minus 1 over 1 multiplied by the reciprocal. You're confusing. Slope is equal to the limit as x goes to 2 of, I have a 2 minus x over x minus 1 times 1 over x minus 2. Do the 2 minus x and x minus 2's cancel? Not quite. What do I have to do? Factor out a negative. Now they're gone. I have negative 1 over x minus 1. Can I plug in the 2? Yep, and you get negative 1 over 1 or negative 1. So that would be the slope. You would simply use your point on your line, which is 2, 1. You would then use that to write your equation for your line. Yeah. 2 right there. We're not going to do example 3. Shh, folks. Just one more thing to kind of bring this together. If you look at the front, first of all, on your study guide, this is a picture that you need to know. You need to be able to put a, f of a, x, f of x, be able to write that limit formula, okay? This is what ties it all together. Second of all, this is definition 1. There is a definition number 2, which is more traditional, something that I like even better, and it would allow us to do example 3. I screwed up during second hour because we actually tried example 3 using definition 1, and it really doesn't work out. So I used to introduce definition 2 as well. We're gonna do that after this test, so don't worry about it. Okay. Oh yeah, you can cross it off, and that's it. No more assignments other than what you got right now. You got time to work.